Okay, so now we will discuss about the instantaneous centers of slider crank mechanism, and here you can read the problem. In a slider crank mechanism, the length of the crank and the connecting rod are 200 mm and 800 mm respectively. Locate all the eye centers of the mechanism for the position of the crank when it has turned 30° from inner dead center. Also find the velocity of the slider and angular velocity of the connecting rod if the crank rotates at 40 radians per second. Now for the same problem, the scale is taken as 1 centimeter is equal to 100 mm, and after that the configuration diagram has been constructed. See here, OA length is given, that is 200 mm, and AB length is also given, that is the connecting rod length, and it is 800 mm, and the crank OA is turned through 30° from the inner dead center. Okay, here we have the slider. Okay, so now this is the slider crank mechanism. So here what we are supposed to do, again we have to calculate the number of instantaneous centers first. For that we have a formula. So this is the formula: n is equal to n into n minus 1 by 2. So here number of links is equal to 4, and therefore the number of instantaneous centers is equal to 6. Now we will give the number to the links. Which are those 4 links that we will identify? See, this is a one fixed link, and this is link number 2, and we have link number 3, and the slider is nothing but it is the link number 4. Okay, and this is again, this is a fixed link, 1 and 1 only. Okay, so here also fixed, here also the slider is constrained here, so here this constraint is also 1 only, so that is nothing but the frame. Slider is link number 4. So now to locate the eye centers, so what is the procedure that we are following? We will write the number of links 1, 2, 3 and 4. 4 links are available. So under each link we will also write the combination of the eye centers, likewise in the previous problem what we have done. So here also, so for any 4-bar mechanisms, so that is these are all the eye centers. So totally we have 6 eye centers. So these are the combinations. So for with respect to link 1, I have I12 and I13 and I14. With respect to link 2, I have I23, I24, and with respect to link 3, I have I34. Remaining combinations are repeated, so that is it may be 32, I32 is same thing as I23 and I43 and I34 with respect to link number 3 and 4. So these are all the eye centers, 6 eye centers. Now we will locate the eye centers on the figure. So come back to this. So by inspection method we can determine some of the eye centers. So which are the eye centers that we can determine? We'll look into that. So this is a fixed link I1. This two, the eye center, since it is having a pure rotation, that is link number 2 can rotate with respect to link number 1. So this is the center of rotation, that is I 1 2, and we'll come back to this. This is also called as a fixed instantaneous centers, and this one is between 2 and 3. If you take between 2 and 3, I 2 3, so this I 2 3. Coming back to this connecting rod, link number 3, and we have a slider 4, so I 3 4, so I 3 4, this is the I 3 4. So this all these instantaneous centers we got it located. So another thing is what, link number I14. Okay, so we have this link 1 is fixed, that is nothing but the frame. So it is link number 1 is there, and you carefully observe link number 4. So this is link number 4. This link number 4 is what type of motion it is having? It is having a horizontal motion. It is having a horizontal motion. So it can only have horizontal motion only. So as the line of the stroke of the slider is horizontal, since the line of the stroke of the this stroke is horizontal, the high center, that is a high center of link number 1 and 4, it will lie upwards or downwards in the infinity. Okay, so the statement is like this, that is the eye centers 1 and 4, that is I14. So with respect to this, so I14 is there. So this I14 will lie at I14 at infinity. This will lie at I14 infinity. This with respect to 1, and this is link number 4. So again, this is also I14 only. This is also I14 only. This vertical line, upwards or downwards, it will lie at infinity. Okay, I14 will lie at infinity. This is why, because this 4 is horizontal and this is link 1. So the eye center, that is eye center has to lie on anywhere on this line, but it lies at infinity, so it is not possible. Okay, so far we are able to locate I12, I23, I34 and I14. So we'll come back to this table, so that means we are able to locate I12 is located, so we can round it off, and I23 is also located, you can round it off, and I34 is also located, you can round it off, and along with this I14 is also located. So all these are by visual inspection only, all these eye centers has been located. It is I12, I23, I34 and I14. Now what is left over? Left over is I13 and I24. So I want to locate I13 and I24. So how to locate that? Again I will use the same method what we have used in the previous problem. That is you can have a square, and you start from this point only, that is start numbering this square from 1 2 3 and 4. So I have numbered the square 1 2 3 4. Now what is the eye center I require? That is I13. So you join this I1 and 3, that is 1 and 3 you join this use this diagonal 1 3. So now this is nothing but I12 with respect to link number 1 and 2, and this point is nothing but I23 with respect to link number 2 and link number 3, and this point is nothing but I 1 2 I23, and this is I34. Okay, so this is I34. So now I will use this diagram so that I can get the unknown I13. The location of I13 I can find out. So I13, where it has to lie? I13, it has to lie on the line joining all these three I centers, because I13 according to Kennedy's theorem, it can lie on line joining these three I centers. Okay, so now we'll go back to this figure. So I12, so where is I12? This is I12 and I23. This is I23. Okay, so the line has to come from I12 and I23.